Hi, this is Math 7, Unit 7, Lesson 2, talking about adjacent angles. And by adjacent angles, we mean ones that are, in a sense, next to, or as I talk to my kids sometimes, being next door. They live side by side each other is what it means to be adjacent. So you can turn to the person next to you and say, hello, you are adjacent to me, and it's nice to be your neighbor. All right, here we go. So we're going to take a look at, first of all, some estimating angle measurements. We've talked about some angles the other day in our first lesson. We talked about some special angles that we called right angles, right, which were the corners of a book. And those right angles were 90 degrees. We saw those in our squares. We also talked about our straight angles, which were a full line. And those straight angles were 180 degrees. Okay, knowing what we know about some of our shapes, if we took an equilateral triangle, so angles like this around this size, we're about 60 degrees there for an equilateral triangle. So just keeping some shapes that you know in mind as we look at this first activity. It says, estimate the degree measure of each indicated angle. All right, so in this first one here, you can estimate that. I know it's curved there. If I was to put a pattern block in there, we could see and verify that that is actually going to be a 90-degree angle. Again, they're not asking you to really measure that, but that looks like about a 90 degrees. So if that's 90, then what would this be? We can tell it's a little bit less than 90. How much less? I don't know. Again, is that an equilateral triangle? So it's not 60. It's bigger than 60, less than 90. I don't know. Let's just go with maybe like an 85 degrees. It's a little bit less, right? If the straight line is here, right? So it's just that space difference. Hard to say. This one, if 90 is here, seems to be that little bit more than 90, right? So it's like the opposite tilt. So if I subtracted 5 here, let's add 5 to 90 there and make that 95 degrees. Again, I am just doing what? I am estimating. So I'm not getting out my special protractor here and saying, oh, let's find out for reals. Here, this one looks like about, again, that's our 180 degree it looks like. Okay, and I gotta check that out with the bottom of a square because that's a straight line. Yep, sure is. Here, we are a little less than that, right? So if my straight line went this way, we're taking away from 180. Let's just take away 5 again, 175 degrees. And here, probably about adding back the 5, so maybe 185 degrees. Great. In this picture, we can see that I have, looks like a straight angle, or 90 degree angle here, which is 90. Because I'm talking about the space around the other side of that, it's going to be the circle 360 minus that 90, which is going to be 270 degrees, would be my estimate. I don't know for sure if that's true, but this sure does look like a 90 degree angle right there, which would mean that what's left of that circle is 270 degrees. In this one here, we're talking about the angle going from here all the way around. So we're almost at a full circle, right? Almost at a full circle, but maybe not quite. This little space that's kind of taken out of that, how much of that, what is that space going to be? Well, it doesn't look to be that much bigger than perhaps this space here at 85. We called that 5 degrees, so maybe inside of there is about 5 degrees. I'm not sure, but we know the whole circle is 360. Let's just go ahead and take away 5. So we have 355 degrees for this angle measurement all the way around there. Is it accurate? It's an estimate, so it's just fine, okay? All right, let's take a look at your first activity today, really. So we have actually called cutting rectangles. And your teacher gives you 2 small regular papers, okay? And on each paper, they want you to draw a small half circle in the middle of one side. So let's take my paper here. All right, I'm gonna just get myself a rectangle paper. Just cutting up some patty paper real quick. Right, so I have my rectangle there, awesome. Okay, now on one of the papers, draw a small half circle in the middle of one side. Okay, so here's my paper. Let's draw a half circle from here to here. Awesome. There's my half circle on that paper. Looks great. Cut a straight line starting from the center of the half circle all the way across the paper to make 2 separate pieces. Your cut does not need to be perpendicular to the side of paper, meaning I can make whatever cut I want. I can go up, let's cut like this, and go like that. Awesome. So I chopped that little 180 degree into something along those lines. Cool. On each of these 2 pieces, measure the angle that is marked by part of a circle. Label the angle measure on the piece. Okay, so to do that, we need to take a look at our protractor. Okay, and I'm going to line up the side. Okay, so let me make this a little bit darker so we can see what we're doing here. Here's the side I'm talking about, and here's my angle there, and I'm going to come out to this place right there. All right, so now we're going to slide our protractor on top. I'm going to put my protractor line on the line, and I look and see where this is going, and from here to here, looks like I cut an angle on that line at about 70 degrees. Okay, and so the reason I say that is, again, if I was to make this a little darker for you to see, let's see if I can get a Sharpie out here. Let's sharpen that up there. I'm just coloring all over the place here, making a giant mess. That's okay. I want you to be able to see here. So if I take that space, that's what I'm measuring in the blue, I put my protractor on top, make sure that your line where 0 is on the line of that angle there, and that your circle hole there is right there where it goes. And I can see the blue goes here to here. That looks like about 70 degrees there. Okay, 70 degrees on that piece right there. I'm going to look at this piece right here. Let me go ahead and color that in real quick like the last one. So let's color here, and I'm going to color here. I'm looking for this angle measurement there. All right, so let's see what happens on this one. So this side, I start on the other part. I start on the outer number 0, and I go all the way around this way, 0 to 110, because I'm going this way, starting from 0 and counting up to there to get 110 degrees. So this is 110 degrees. Cool. So that's what I have so far. So we measure them. What do you notice about these angle measurements? Well, what you might notice is that 110 plus 70, they add up together to still be my 180 degree straight angle that I started with. Okay? Cool. That's what you notice first of all. Next, what we want to do is Claire measured 70 degrees on a paper, predict the other angle. Well, we can do it because we actually cut it by 70 an accident. How can we predict it? If you weren't sure, what you would do is you'd say, well, I know that straight is 360, and if I subtract 70 from that, that will give me the missing piece. So 360 minus 70, we've already discovered is, 180, apologize there. 180 minus 70 is going to be 110 degrees. So that's how she could figure it out. So if you measured one side and you found one of them was 40, you could figure out the other side by doing subtraction. On the other rectangular paper, draw a small quarter circle in one of the corners, and then do the same thing as before. Let's chop it up. So I'm going to just draw it on here. Here's my patty paper. So I have this line right there. I have this line right there, and then we're going to go ahead and chop this up. So I have the whole space is here. And again, it doesn't matter where you want to make your cut at, you can make it wherever you want. I'm going to just chop from the corner and go straight across like this. All right, so I chopped it up like so. Now let's do some measurement. Okay, let me draw a little line here so I can see my edge a little more clearly when I do the protractor and see what I end up with. So let's take a look at the first one. Let's start right here. Get my line on the 0 line, put my line there, and what do I see? Looks like cutting here, I am a little less than 70. I'm maybe about 68 degrees. Okay, so 68 degrees. Awesome. Okay, can I figure out the other piece? I sure could. I could do math with it, or I could actually measure it. What's the measuring thing, right? If I know it started at 90 and I already have 68 degrees, this piece is going to be whatever is left. So I should end up with something around 22 degrees is what I should end up with. But let's just take a look at it for real and see. So I put it on my paper. I pop it right there. Blue line on the 0 going this direction, and what am I at? Something like 22 degrees is just fine. And if you measured it and you said, oh no, it was 25 degrees and you get something greater than 90, it just means you measure your protractor a little bit off. It's not super precise, okay, but it does work out just fine. So in my case, my line was like this, and I had a 68 and a 22, okay? So Priya measured 53 degrees on one of her pieces. Predict the angle measure of her other piece. So to predict that, you take the 90 that you know, subtract the 53 for the first piece, and that would tell you what's left, which would be 37 degrees on Priya's other piece there. All right, kind of cool. And so we're talking about different types of angles here and how they come together to make a 90-degree angle and a 180-degree angle. Now, before we move on, there's a special name for these things, right? When I put an angle together and I combine them, if they form together to make 180 degrees altogether, we call those angles a supplementary angle. If they add up together to make 90, we call that a complementary angle. All right? And so that's really what we were showing right now in working out those two little practice things. Let's take a look at the next activity where we're going to be looking at whether an angle is a complement or a supplement. Okay, so this first one. For the first one, we say use a protractor in the picture to find the measure of the angle. So we have BCA is our first one, so angle BCA. So going from here to here to here, what is this angle measurement? We start at the 0, we're going all the way to there. The space is BCA, and we can see it gets to where? It gets to the 30. So this has an angle measurement of 30 degrees. For BCD, our next one, going from B all the way up to D, we can see our angle measurement is right there at 90 degrees. 90 degrees. Explain how to find the measure of angle ACD without repositioning the protractor. Can I figure out this angle measurement right there without realigning the protractor? That's our question. And sure we can. We know the 90. We subtract what we know of the 30. So this piece minus this piece will give us that piece. That will give us our angle ACD. So 90 minus 30 is 60 degrees. So angle ACD is 60 degrees. Another way of thinking about it is I could also say, because it's complementary, because I know 30 plus what other angle measurement, 30 plus what, is going to add up to 90. And so that's the other way of writing that out in terms of like an algebraic expression. 30 plus x equals 90. Okay, and this is what we do when we talk about a complementary angle. I always think of a complement as you get a complement sometimes when you do something right, and a right angle is 90. Let's take a look at some supplementary ones. Okay, so now we have LOK right there, and LOK goes from here to here. A little different there. It's not quite 40, it's over 35, so maybe 35, 36 or 7, maybe 38 degrees right here in this space for LOK. 38 degrees. Now LOM is from here all the way to the M line, right? The L line around the O all the way to the M line. So that's going to go from 0 all the way around to 180. I know it says 18, but it really is 180 degrees. So it's a straight angle. How do you find the measurement of angle KOM? This space, KOM, right there, that's what we don't know, without repositioning. So again, we already know I have a 38. I'm going to add some more to it, this bit, in order to get to the whole thing, which is 180 degrees. This is finding a supplementary angle. I could do it like this, and if I solve for x like this, what would I do? I would subtract 38 to solve for x, and 180 minus 38 is 142 degrees. So this little question mark area is 142 degrees is what's there. So again, I could set it up as 38 plus x equals 180, or I could do 180 minus the 38 that I already know, which is still equal to 142. That's what I did right here, but here I did it with an algebraic equation, not just a number there. All right, let's take a look at the next one. Number 3, angle BAC. BAC is a right angle. What does a right angle mean, guys? Right angle means 90 degrees. So this whole space right there is actually 90. Find the measurement of CAD. So find this angle right there. We want to find out that space. So what do we know? We know that I have 64 already. Check. And when I add this part right here, we'll call this X, it's going to add up all together to 90. And that's what we know. So let's subtract 64 from both sides. So that X equals 90 minus 64 is 26. So angle X, or angle CAD, is going to be 26 degrees. That's the cool idea. For P, point O is on line RS. That's the line. Find the measurement of SOP. So now we're trying to find out this space right here. Again, this is a supplementary angle. So altogether, we know the whole thing is 180 degrees, right? We're given a 76. So a 76 degree angle plus the I don't know angle, call that X, is going to combine to form a supplementary angle, which is going to be equal to 180 degrees. So now we can find out what the missing angle measurement is by subtracting 76 from both sides. We have X over here, and 180 minus 76 is going to be equal to 104 degrees. So this little space right here is 104 degrees. Very, very cool. All right, let's take a look at your lesson summary. Let's see what we have here. Summary today. If two angles measure up to 90 degrees, then we say the angles are complementary. Here are 3 examples of pairs of complementary angles. Notice that in these pictures here, when we talk about complementary, they do not have to be adjacent to be complementary. It just means two angle measures, 2 angle measures that add up to 90. So here, yep, they're side by side. Here, they're across from each other, but they still add up to 90. And here, they're 2 parts of a triangle, but they still add up to 90. That is just fine. So keep in mind, anytime you can add 2 angle measurements to 90, we call it complementary. The same is true for 180. 2 angle measurements that add up to 180, we call supplementary. So here, these side-by-side ones add up to 180. Here I have a 90 and a 90, and those combine to make what? 180. And in this case here, this angle by itself and that angle by itself all add up to be 180 degrees, and we can still say that they are supplementary. We're going to pause there while you do your homework, and then you'll come back and check it together in just a moment. Okay, here's today's homework. It says angle A and C are supplementary. So this plus this is supplementary. Supplementary means what, guys? It means 180. So A plus C equals 180. Find the measure of angle C. Well, we know that A is 74. We don't know what C is, but we know since they're supplementary, they're going to add up to 180. So we subtract 74, we subtract 74, so that angle C is equal to 106 degrees. 106 degrees. Number 2, list 2 pairs of angles in this square right here, CDFG, that are complementary. All right, so there are multiple answers here. You just want to make sure that what? That 2 pairs add up to what? Complementary means 90 degrees. So here's a couple options. You could do D and C and M. So this one, so angle DCM, which is 27 degrees, and I could do DMC, angle DMC, which is 63 degrees. That all equals what? 90 degrees, and you're good to go there. Okay, that's one example. Are there others? There are a lot of others, and I'll let you do those, and I'll just give you one example to get you started. So that plus that equal 90. You can find others, you can do it different ways, go for it. B, name 3 angles that sum to 180. Now this time we're doing 3 angles that get you to 180. All right, cool. So let's see what we can do. We want 180. 180 is going to be a straight line, right? That's a straight line for 180. So for me, I went ahead and said, well, I like this straight line right there. That's a nice easy one. So what angle is this one? This is going to be called DE. DMC, so angle DMC plus angle CMG plus angle GMF are all equal to 180 degrees. There's 3. That's all you have to do. Are there others? Yep, there sure are. Okay, so you can find some more. You can find some that add up to 180, whatever you want to do. Cool. Number 3. Complete the equation with a number that makes the expression on the right side of the equal sign equivalent to the expression on the left side. So we want to put a number right there so that this matches that part right there. All right. So what we can see, first of all, let's do some combining of some stuff on this side. Let's put a 5x with a 6x. Put those together to make that an 11x. Let's do a minus 2.5 and a minus 3 to combine it to a minus 5.5. Okay, and that's still going to equal something times 2x minus 1. Okay, so what you can think about here is you have to have a number that you're going to multiply both of these by to match that. So you have to ask yourself, 2 times what number can get you to 11? Okay, how do you get to 11 from a 2? Well, think of it this way. If I use a fraction and do 11 over 2, what happens to the 2's? The 2's go away, so what's left? Just the 11. So what number can we put right there that's going to work? I would say we'd put 11 over 2, because that's going to work. Does it work for the 1? Let's see. 11 over 2 times a 1 is going to be 11 over 2. That's 11 over 2. So now what? Is that equal to 5.5? Well, 2 goes in there 5 times. With 1 left over, 5.5 sure does match 5.5, so we're good. So our answer would be 11.2. And finally, our last one for the day, we're going to match some tables with the equation that represents proportional relationships. All right, and so what we have here, we have y equals 1.5, 1.25, and 4. All right, so let's take a look at what's happening here with the different values that we have. So if I put a number in, let's put 2 right here. If I put 2 in here, what is 4 times 2? That equals 8. That matches there. If I put 3 for x, what is 4 times 3? It equals 12. Okay, so that seems to work pretty nicely for there. So this one matches A. So this one goes with A, no problem. That was easy. Now we're looking at these ones. We have 1.5 and 1.25. Again, I could just put some numbers in and try it out and see what happens. That can work. So let's just see. Let's try it with a, well, what do you want to try it with? Let's try it with a 6 right here. Let's do this one. Let's do 1.5 times 6. And I'm going to do 6 because I have a 6 here and a 6 here. And let's see which one it works for. So 6 times 1.5 is equal to actually 9. So if I have 1.5 times 6, that's not 9. 2 goes into there 7 times, so I end up with 7.5 as an answer there. So knowing that if the x value is 6, which one of these tables produces a y value of 9? It's going to be this one right there. So 1.5 goes with this one, which remains the 1.25 goes with that one right there. All right, and that is it for the day. Hope that helps you out, and we will see you next time.